Hi, we are from At Home Tuition. In this video, we are going to see the next interesting pattern, sum of consecutive natural numbers. That is, we are going to see how to express the given square number as a sum of consecutive natural numbers with few examples. The first question is, explain with example how to express square number as a sum of consecutive natural numbers. So, consider the following square numbers. So, first we will take 3 square. So, you know that 3 square is 9. So, 9 can be expressed as 4 plus 5. Then if you take the next number, let us take odd numbers. Okay, 5 square. So, 5 square is 25. 25 can be expressed as 12 plus 13. So, next is 7 square, 49. So, it can be expressed as 24 plus 25. Similarly, 9 square can be expressed as 81. So, which is 40 plus 41. 11 square is 121, which is equal to 60 plus 61. 13 square is equal to 169, which is 84 plus 85. Then 15 square is 225, which is 112 plus 113. So, if you look into all these examples, so if you take the first example, so it's 3 square. So, I have written it as 4 plus 5. So, how I got this 4 is 3 squared minus 1 divided by 2. That is 3 square we know. 3 square minus 1 divided by 2. Then how I got 5 is 3 square plus 1 divided by 2. The same way, if you take this 5 square, which is 25, so I have written as 12 plus 13. So how I got this 12 is 5 squared minus 1 divided by 2. So 5 square is 25 minus 1 is 24. So 24 divided by 2 is 12. Same way, how I got this 13 is 5 square plus 1 divided by 2. So, 5 square is 25 plus 1 is 26 divided by 2 is 13. So, I got all these numbers, this 24, 25, 40, 41, all these numbers I got by using this formula. So, in generally, I can write if the number is n square, then I can write this as n square minus 1 divided by 2 and the other number is plus n square plus 1 divided by 2. So, thus we can conclude that square of an odd number can be expressed as sum of consecutive natural numbers given by this formula. So, the formula what we got is n square is equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So, n is an odd natural number. So, we can express square of any odd numbers as the sum of two consecutive positive integers. Now, our first example is express the following as the sum of two consecutive integers. So, the given question, first question is 21 square. So, solution, we know that square of an odd number can be expressed as sum of consecutive natural numbers or positive integers. So, it's given by the formula n square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So, n should be a natural odd number. So, the first given number is 21 squared. So, now we know that 21 is an odd number. So, its square can be expressed by this formula. So, n square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So, here n square is 21. So, I have substituted in this formula. So, 21 square minus 1 divided by 2 plus 21 square plus 1 divided by 2. 21 square is 441 minus 1 divided by 2 plus 441 plus 1 divided by 2. So, 441 minus 1 is 440 divided by 2 plus 441 plus 1 is 442 divided by 2. So, 440 divided by 2 is 220 and 442 divided by 2 is 221. So, thus 21 square can be expressed as 220 plus 221. So, which is sum of two consecutive positive integers or positive natural numbers. The next number given is 13 square. So, we know that 13 is an odd number. So, its square can be expressed by the formula n square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So, now instead of n square, I am going to substitute 13 square. So, 13 square minus 1 divided by 2 plus 13 square plus 1 divided by 2. 13 square is 169 minus 1 divided by 2 plus 169 plus 1 divided by 2. So, 169 minus 1 is 168 divided by 2 plus 169 plus 1 is 170 divided by 2. 168 divided by 2 is 84 plus 170 divided by 2 is 85. So thus 13 square can be expressed as 84 plus 85. So this 84 and 85 are two consecutive positive integers. The next number given is 11 square. So 11 is an odd number. Again we can use the formula n square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So here n square is 11 squared. So 11 square equal to 11 square minus 1 divided by 2 plus 11 square plus 1 divided by 2. So 11 square is 121 minus 1 divided by 2 plus 11 square is 121 plus 1 divided by 2. So 121 minus 1 is 120 divided by 2 plus 121 plus 1 is 122 divided by 2. So 120 divided by 2 is 60 plus 122 divided by 2 is 61. So 11 square can be expressed as 60 plus 61, where 60 and 61 are two consecutive positive integers. The next number given is 19 square. Since 19 is an odd number, we can express this 19 square as a sum of two consecutive integers using the same formula. N square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So here n square is 19 square, which is equal to 19 square minus 1 divided by 2 plus 19 square plus 1 divided by 2. We know that 19 square is 361. So 361 minus 1 divided by 2 plus 361 plus 1 divided by 2. So 361 minus 1 is 360 divided by 2 plus 361 plus 1 is 362 divided by 2. 360 divided by 2 is 180 plus 362 divided by 2 is 181. So thus 19 square can be expressed as 180 plus 181, which is sum of two consecutive positive integers. Next question is, do you think the reverse is also true? That is the sum of any two consecutive positive integers is a perfect square of a number? Give example to support your answer. So solution, I am saying that no. The reverse, that is the sum of any two consecutive positive integers is perfect square of a number, is not always true. Okay, sometimes it's true, but it's not always true. So I'll give you an example why it's not true always. So we have proved how it is true for odd numbers. Okay, so now I'll give you an example why it's not always true. So they have given two consecutive positive integers. So now I am going to take for an example two consecutive positive integers, say 3 and 4. So these are also two consecutive positive integers. Now our question, sum of two consecutive positive integers. So I am going to sum the two consecutive integers, that is 3 plus 4, which is 7. So our question is it a perfect square of a number? So we know that if you sum, you will get a 7. So we know that 7 is not a perfect square of a number. So the sum of any two consecutive positive integers is perfect square of a number is not always true. Here I am giving one more example to support the answer why it is not true. See, I have considered a number 4 square. So we know that square of a number can be expressed as sum of consecutive natural numbers given by the formula. N square equal to n square minus 1 divided by 2 plus n square plus 1 divided by 2. So now I have taken it as 4 square. So now it's applying here. So 4 square minus 1 divided by 2 plus 4 square plus 1 divided by 2. 4 square is 16 minus 1 divided by 2 plus 16 plus 1 divided by 2. So 16 minus 1 is 15. So 15 by 2 plus 17 divided by 2. So this by 2 is not a natural number. So what we have done, it's a sum of two consecutive natural numbers. So it's not a sum of two consecutive natural numbers. So therefore we are concluding that square of a number cannot be always expressed as a sum of consecutive natural numbers. Hope you have understood all the questions well. Thank you for watching the video.